Hello everyone. We've been learning about similar triangles in our past few videos. What we have learned so far is that the triangles were similar if their shapes were intact. The shapes of the triangles were the same, but the sizes may differ. So that is how they looked similar to us. And we saw that if corresponding angles in similar triangles were equal, then the corresponding sides were in proportion. We in fact proved this in our third video. We proved that if this was ABC, if this triangle was ABC and the scaled up version was DEF, we proved that this ratio DE by AB was equal to EF by BC equal to FD by CA. That is, if the angles were equal, then the sides were also in proportion. But now here in this video, we are going to prove the converse of this theorem. Let me state it first. We are going to prove if the corresponding sides of two triangles are in proportion, then the corresponding angles are equal. This is what we are going to prove in this video. And hence these two triangles would be similar. So we have started with this, that the sides are in proportion. And we know nothing about these angles. I'm just erasing these angles here. We know nothing about the angles. We are just going to find that they are also equal. So let us proceed. Like in our earlier examples, or the earlier way we proved the first theorem, we'll just measure AB, place a compass here, measure AB and cut an arc here at P. So DP would be equal to AB. So AB is equal to DP, and similarly measure the length AC and cut an arc on DF at Q in such a way that the length of AC is equal to DQ. Now let's join PQ. Of course, we could have shifted it. The triangles would be exactly the same if we had shifted, but since for notebook purposes, I think this would be better. So now, what do we have? We have PQ, which divides DE and DF, but we do not know the ratio in which it divides. Let's try to find if there is any particular ratio. Now just look at this, what we have. We have DE by AB and we have DF by AC. So let's use this ratio, DE by AB and DF by AC. And in the place of AB, I think we can write DP because AB is equal to DP. So let me start from the beginning. We have DE by AB is equal to, what is our last ratio here? DF by AC. So instead of AB, I'm just going to write it as DP, right? So because AB is equal to DP, and instead of AC, let me rewrite it as DQ. So DE by DP and DF by DQ. But we have to find whether there is any relation between DP, PE, DQ and QF. So for that purpose, let's have DP as it is in the denominator. We need it. And let us just subtract 1 from both sides and see what happens. You have DE minus DP by DP is equal to DF minus DQ by DQ. Now look at DE minus DP, you've got P, right? DE minus DP is P, and similarly the other numerator, DF, the whole thing, minus DQ, this part is QF. So I think we got what we wanted. We wanted a ratio between these two and we got it. We now have DE minus DP is PE by DP is equal to QF by DQ. And this says, this particular ratio says that PQ divides both the sides. PQ divides both the sides in the same ratio. So can we conclude that PQ is parallel to EF, because we have the basic proportionality theorem which says that whether it divides in the same ratio, then it is parallel, or if PQ is parallel to EF, then they divide in the same ratio. So now let us conclude that PQ is parallel to EF, right? So if PQ is parallel to EF, we know that these two triangles would be equal. Just look at PQ and EF, there's nothing else to look at. Look at PQ and EF. P is equal to angle E, they are corresponding angles, and angle Q is equal to angle F. They are also corresponding angles in a parallel line. So angle P is equal to angle E and angle Q is equal to angle F, right? Now, since these two angles are equal and you have this ratio here, let me call this ratio as 1. Let me just try rewriting this ratio once again as DE by, instead of AB, I'll write it as DP is equal to DF by, instead of AC, I'm using this one, DQ. Instead of AC, I'm writing DQ is equal to EF by BC. I'm just rewriting the ratio in terms of DP and DQ, but I'm not able to replace BC. So I'll have to find a way to replace this BC. What do we do to see if BC is equal to PQ so that I can replace it by PQ? Let's think. We know that these two angles are equal, and in these two triangles, consider the two triangles now, DPQ and DEF. If you consider triangle DPQ and triangle DEF, just rub the and here, you will know why very soon. What do we have? We already have angle P is equal to angle Q and angle E is equal to angle here. We have angle P is equal to angle E, and angle Q is equal to angle F. But observe the last angle D, it's common, right? And even otherwise, if two angles are equal, the third angle has to be the same. But in this figure, it is common to both. So can I conclude that these two triangles are similar to one another? Yes. So if DPQ and DEF are similar, I can write it as the corresponding ratios, the sides, the corresponding sides would be in the same proportion, right? So I will have this ratio now, DE by DP is equal to DF by DQ, and my last ratio would be PQ by, right? Because it's DE, DF, I'll have to write EF in the numerator, EF by PQ. But look at these two ratios now. This is EF by PQ. All the rest are the same here and here both are same. Just that these two things differ a little. By EF by BC and EF by PQ, they have to be equal, isn't it? Because all the rest are equal. So we have EF by BC is equal to EF by PQ. So what does this imply? If you cross multiply and see, you will be getting BC is equal to PQ, right? In these two triangles, now this BC is equal to PQ, but already we knew that these two sides were equal. These two sides were equal. So can I conclude that they are congruent by the SSS congruency? Triangle ABC and triangle DPQ would be congruent, isn't it? Just tick it down so that we can write near that. Anyway, we'll have to go up and down to so we have these three sides common. Three sides are equal. AB and DP. This is C. So by SSS congruency, because all three sides are equal, you have triangle ABC is congruent to triangle DP and Q, right? Because AB is equal to DP, AC is equal to DQ, and BC is equal to PQ, which we proved just now. We were waiting for this actually, right? That the third side also were equal. So these two triangles were congruent. So what do you infer by the congruency? The triangles would be equal. That is, angle A would be equal to angle D, and angle at B would be equal to angle at P, because these are the triangles which are congruent, and angle at C is equal to angle at Q. But we already know that angle at P is equal to angle at E, right? And Q is equal to angle F. So let me replace P as E here. Let me just write, instead of P and instead of Q, I can write, use a different color pen. This is E, and angle C would be equal to angle F. So look at this, we have in ABC and DEF. Now we are talking about these two triangles, triangle ABC and triangle DEF. We know that all the corresponding angles, B is equal to E and C is equal to F, they are equal. So the two triangles are similar. The corresponding angles are equal is what we wanted to prove. We started off with the corresponding sides are in proportion. That is this. And now we have proved that the corresponding angles are equal. I think if you pause the video and relook at it a few number of times, you would be able to follow this proof, though it's a little long one. It's very easy. Thank you.